Welcome back, students. We are now going to do the part 2 for this question. Now, we are expected to show that a times b equals 0 and b times a equals 0, but a should not be equal to 0 and b should not be equal to 0. This is a very tricky question. You know why? In school, you would have studied that if AB is equal to 0, then either A should be equal to 0 or B should be equal to 0. But this is not true when you are dealing with matrices. So that is the reason you have a special branch, what is called as matrix algebra. So whatever properties that you study in algebra will not work in matrix algebra, of course, bearing a few exceptionals. Okay, having said that, to prove this, I'm going to be considering the matrix A to be of the form 1, 1, 1, 1, and the matrix B to be of the form negative 1, 1, 1, negative 1. So now let us consider multiplying A times B. So that would be 1, 1, 1, 1 multiplied with negative 1, 1, 1, negative 1. So the row with the column, I take the row against the column. So that would give me 1 multiplied with negative 1, positive 1 multiplied with 1. The row with the column, 1 multiplied with negative 1, positive 1 multiplied with 1. Row with the column, 1 multiplied with 1, positive 1 multiplied with negative 1. Row with the column, 1 multiplied with 1, positive 1 multiplied with negative 1. So this is going to be equal to negative 1, positive 1, negative 1, positive 1, 1, negative 1, 1, negative 1, which clearly is going to be 0, 0, 0, 0. So this is the product of A times B. Now let us consider multiplying B times A. So the matrix B is negative 1, 1, 1, negative 1, multiplied with matrix A, which is 1, 1, 1, 1. So take the row with the column. So negative 1 multiplied with 1, positive 1 multiplied with 1. Take the row with the column, 1 multiplied with 1, positive negative 1 multiplied with 1. Again the row with the column, negative 1 multiplied with 1, positive 1 multiplied with 1. Again the row with the column, 1 multiplied with 1, positive of negative 1 multiplied with 1, which would give me negative 1, positive 1, positive 1, negative 1, negative 1, positive 1, positive 1, negative 1. Upon simplification would give me 0, 0, 0, 0. So this is B times A. Now comparing B times A with A times B, clearly you can write, clearly AB equals 0 and also BA equals 0. But the important point here is neither A equals 0 or B equals 0. So neither A equals 0 nor B equals 0. So that is the expectation for this question. So that ends the proof.